Welcome back to Frequency Online Math. So we'll be talking about binomial distribution. We are still under types of discrete probability distribution. Now we are going to talk about this binomial distribution. So what is this binomial? The summary of this binomial distribution is just trying to tell us this binomial distribution is n successive trial of a Bernoulli distribution. When you repeat Bernoulli distribution more than you know that Bernoulli distribution is what? One trial. But when you do more than one trial, you are now doing what? Binomial what? Distribution. But it have conditions. The condition is that the trials must be independent of themselves. That's the n trials are independent. And the second is that they must have two outcomes, success and failure. And the third one is that the probability of success will be the same throughout the whole trial. So that's it. So let's read from the board. Binomial distribution is a common probability distribution that models the probability of obtaining one of two outcomes under a given number of parameters. It summarizes the number of trials when each trial has the same chance of attaining one specific outcome. Now, note that the binomial experiment is n successive trial of a Bernoulli experiment. Now, the characteristics of Bernoulli distribution, the n trial are independent. There are only two possible outcomes in each trial. The probability of success remains the same from trial to trial. Now, let me analyze this thing we have just explained now. So, remember, if you have a coin and you have what? A head and a tail, right? So this one is what? Bernoulli distribution. You have a coin, it have two possible outcomes, head and what? A tail. When you flip a coin once, you are going to obtain what? Head or a you have two possible outcomes, head and what? Tail. These are the two possible outcomes. You can obtain head or tail. Maybe you tell yourself that probability of obtaining head is success, the probability of obtaining tail is what? Failure. Now, what if you flip this coin multiple times, multiple times? Flip two or coin two. You are flipping this coin multiple times. So do you see that you are now performing what? Bernoulli distribution. You are flipping it multiple times. This one is the first flip, second flip, third flip, fourth flip. So you are getting what? Independent outcomes. Independent outcome in the sense that if you flip this one, you are getting two possible outcomes, right? You can get head or what? Tail in the first flip. Now this one, you can get what? Head or tail in the second flip. This one the same, this one the same. So flipping the coin more than one times, you are performing what? Binomial distribution. And see the conditions, the n trial are independent. What you get here will not affect what you get here. It will not affect what you get here. It will not affect what you get here. That means that there are what? The n trials are independent. You know what independent probability means? The type of probability that the outcome of one event does not affect the outcome of what? The other event. So there are only two possible outcomes in each trial. As you can see it, this one is first trial, two possible outcomes. Second trial, two possible. Third trial, two possible outcomes. Fourth trial, two possible outcomes. Till you finish any number of trials, they might ask you that they flip the coin 8 times, depending 12. The probability of success remains the same from trial to trial. Now, for example, I will say that this my head is what? Success. That's whenever I get head is what? Success. So probability of success remains the same. Anytime if this second coin now, if I flip it, I get head, that means it's what? P, which is what? Success. Now if I go to this second coin, if I flip it, I get head, is P. P to success, it will not change to getting P as success. I will now change to T to be my success. No, that means it does not follow binomial distribution. It's trying to tell us that probability of P success remains the same from trial to trial. So if H is your success, it will still be your success from trial to trial. So I'm going to clean this board, and we are going to talk about the formula for as PMF for probability mass function for binomial distribution, and we talk about the mean, the variance, and the standard deviation. So this is the PMF, probability mass function of our Bernoulli binomial distribution. So our P of x is equals to n combination x, then P to the power of x times Q to the power of n minus x, where our n is the number of what? Trial. It depends on the time you perform the experiment. Now our x is the number of successes desired. So that's our x. Now P is the probability of getting success in one trial. So since we know that P is success and Q is what? Failure. So if your name is Peter, that means you are successful. Oh wow. Let me tell you something. My name is Peter. So I'm successful. Yes. So binomial distribution is trying to tell me that I'm successful. And amen, I claim it. So Q is equals to 1 minus P, which you know is equals to the probability of getting a failure in one trial. So you know that from combination formula, when you have n combination r, that is equals to n factorial over n minus r factorial. So I can use it to deduce another formula from this our main formula. So I can write this in as n factorial over n minus x factorial, then x factorial, and I'm going to put my p to the power of x, then q to the power of n minus x. This formula can still work. If you don't want to use this one, you can use this one. They are still the same thing. So now I'm going to give you the formula for mean. This is mean represented with what? Mu. Mean, the formula for mean is n times p. So our formula for variance denoted as what? Sigma squared is what? N times success times failure. Then our formula for standard deviation denoted as sigma is square root of n times p times this, or you can still write it as square root of n times p 1 minus p. So they're still the same thing. So this is the formula. You know that Q is 1 minus P, right? So thank you for watching. In our subsequent videos, we'll be solving examples on this binomial distribution. Bye bye.